Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ifam Sukri, and in this video, I'm presenting about question number 3 and step by step how to answer it. The question number 3 involves two questions, and the first question involves source transformation, and the second question involves Thevenin's theorem. So, without wasting any time, let's continue with the question. Alright, this is the first question, which is question A of question 3. And it says for the circuit shown in figure Q3A, determine the current I0 using successive source transformation. And for this question, I'll transfer this circuit into a simulation software so that it's better to look at and it is easier to transform the circuit. Let's move on. This is how the circuit looks like when I transfer the circuit to a simulation software. And now, what is it that we need to do first? Okay, first that we need to do is to look at what can be transformed. And from what I see, we can transform the series of resistors and the voltage source. And we can also see the resistors of 20 ohm and 20 ohm. And we can calculate both of this, and for the resistor we get 40 ohms since it is in series, so we just add it up. And for the resistors and voltage source, we need to know the current source since we want to change the voltage source to current source. So we use the Ohm's law, which is V equals to I, V equals to IR. So to get I, we just need to divide the resistor. We need to divide the value of voltage and the resistors, and then we get the current source. Alright. After we are done calculating the voltage source and the series resistors, we change the part of the calculated area to like this. Why is it that we parallel the current source and the resistors? The reason for that is because to change the current source, the condition is when the voltage source is in series with the resistors, or the current source is in parallel with the resistors. Now let's continue with what we are doing. Now let's focus on these two resistors and these two current source. And after that, we can also focus on the voltage source of 10 volt and the voltage source of 20 volt. Our aim here, we change the voltage source to current source so that we can parallel all these resistors and we can add up the current source that we got. Now, since we want to parallel these resistors, so we just parallel it like a normal way, such as this. R parallel with 10, we get 3.33 ohm. And whenever the current source is in parallel to each other, we can add it up or subtract it. If these two current sources have the same direction, we can just add it up. But if it is in the opposite direction to each other, we can subtract it. And for this part, we just do the same way that we did for this part, which is get the current and we can parallel these resistors and do the same to this. This is what we get after we done calculate the parallel resistors and the parallel current source. So we get 6 ampere and 3.33 ohm. This, alright. And this is also the result of changing the voltage source to current source, and this is the same as this. And now the next step is look at this part. We know that this voltage source and this current source can be parallel to each other, so parallel these two, and after that we get this. The current is 2.75 and the resistors is 4 ohm. After we are done calculating, we got this. And now from what I see, we can change the current source to voltage source, since this two, the current source and the voltage source, is parallel to each other. And the same with this. We got this. And now the voltage source is 6 times 3.33, so we round it, we got 20 volts. And for this one, we got V equals to 2.75 times 4, so we get 11 volt. And we redraw it like this. After that, we look at something we need to do next. For now, let's look at the voltage source. The voltage source is in series, which means we can either add it up or subtract it. If we want to add it up, we must first look at the polarity. If the polarity of the voltage source is in the same direction, which is negative positive and a negative positive, we can add it up. But if the voltage source is in the opposite polarity, we must subtract it, and you got this 20 minus 11, and we get 9 volt. And this part is the series of resistors, so we just add it all up. And after we're done doing that, the circuit will look like this. Since this question is about source transformation, so we must transform the complicated circuit that we got before into one loop circuit like this, which contains a voltage source and a resistor. So to get I naught, we must know the I, the current. So we just use Ohm's law, which is V equals to IR, and we do some algebra, which we get I equals to V over R, and insert the value that we got, and we got 9 over 27.33 equals to 0.33 amp. That is the answer for the first question. Now for the next question, which is question B of question 3, find the Thevenin equivalent circuit at the terminal AB for circuit of figure Q3b, and hence determine the possible maximum power delivered to the load R. From this question, it asks for the load R. Since it says Thevenin's theorem, we must take out the load that we want to learn about. So we take out the load R. It will become like this. Now we are left with this. After that, we must know whether this is case 1 or case 2. With the appearance of dependent source, we know that this is case 2. With case 2, we can't easily get Thevenin's resistance, so we use the formula Thevenin's resistance equals to Thevenin's voltage over Norton's current. We must search for both of this value, which is Thevenin's voltage and Norton's current. To get VTH, I use mesh, but since there is a dependent current source in between two loops, so I have to use super mesh. So this is the way I did it. This is the first equation, second equation, and the third equation. So I just entered it in, or in the case, input it in a calculator, and I got these answers. And since I want to know VTH or Thevenin's voltage, we use I3 or search for I3. So do the formula Ohm's law, V equals to IR. So we get this. 3 is 3 ohm and I3 is this, and we got 4.74 volts. Let's continue with searching for Norton current. To search for Norton current, we must short circuit the node E and B. Whenever we short circuit this, the resistor here will be no use, since the current only flow in this path, and it will not flow in this path because the current will flow the easiest path. So this is the easiest path, the current will flow here. And this is how I use mesh and supermesh to get Norton current. Just the same as before, I use supermesh because of this dependent current source in between two loops. So this is the first equation, second equation, and third equation. And this is the answer for IN, or Norton current. After we get both Norton current and Thevenin's voltage, we insert it in this formula, which is Thevenin's resistance equals to Thevenin's voltage over Norton's current. So 4.74 over 3.2 equals to 1.48. And this is how it looks like when we use Thevenin's equivalent circuit. Now, since we are searching for max power, to search max power we must have Thevenin's theorem. To search for max power we must have one condition, which is load resistance is equals to Thevenin's resistance. If the condition is fulfilled, then we can use Pmax, which is VTH square over 4 times Thevenin's resistance. So this is what we get, 3.795 watt. This is the answer for the second question. The end of the video. So thank you for watching. Bye bye.